Which one do you think is faster? Running animations using CSS or JavaScript? The answer might surprise you, because they are the same. Let me prove that to you using this example. So on this page, we have 3 rotating boxes. Each one is using a different animation method. For example, the first one is using JavaScript and it's running with request animation frame. I'm going to explain that later in this video. And the second one is also using JavaScript, but it's running with WAPI, which stands for Web Animations API. I'm also going to explain that later. And the third one is using the good old CSS animations. Now, the way I'm going to test performance for these animations is by blocking the main thread. Now, don't worry if you don't know what the main thread is or even what a thread is, but you can think of it as the place where all your JavaScript code is running. And when you block one part of the code, then it can't reach the other part of the code. And that other part of the code can contain the animation code, which would cause the animation to either stutter or be completely frozen. So I'm going to click this button, which would block the main thread for 5 seconds. So let's click and see. So you can see that the first one got blocked, but the other two kept running. Now, ignoring why the first one got blocked, the important thing here is that the JavaScript one ran as smoothly as the CSS one, which proves that JavaScript can be as fast as CSS. Now, before I get into the details of how this happened and why we have this, let's go to the code and see how each of these animations is implemented. Let's go there. So let's start with the HTML code. So you can see we are displaying the 3 sections here. Animation type, you can see these 3. And then we are displaying the box here. So we are using the class name box, which would display the box. And then we style each type using box -- then RAF for request animation frame, and WAPI and CSS. Now let's go to the CSS one and start with that. So you can see we have this class box, and we have width 100 pixels and height 100 pixels and some border radius. And if we go to the specific one for the CSS, you can see we are displaying some background color, which is a blue color, and then we have transform, rotate, and it has 0 degrees. So it starts with this value. And then we are defining the animation, and we are naming it rotate, and the duration is 2 seconds, and infinite, and the easing function is linear. And then below that, we are defining the keyframes. And you can see we only have that 2, which is the 100% of the keyframe, and then we are setting transform rotate to 360 degrees. So that means the box will start with rotate 0 degrees all the way to 360 degrees over 2 seconds, and it will run infinitely. So that's it for the CSS. Now let's see the WAPI one. So you can see in WAPI, we have this JavaScript code, and first we are getting the box element using document query selector and using that class name. And then we are calling this method, animate, which takes 2 arguments. The first one is the keyframes, and the second one is the configuration options for that animation. You can see the keyframes we start with rotate 0 degrees, and the final state is transform, rotate 360 degrees. And for the options, we have duration 2 seconds, and easing is linear, and iterations is infinity. You might already have noticed this, but this is very similar to the CSS one, except that we are using JavaScript. So keep this in mind, as this will show you why this is fast as CSS. Now let's go to the third one, which is request animation frame. Again, we start by getting the box, so we are using box RAF, then we are defining these 2 variables, and then this function, and then we are calling request animation frame, and then we are passing that function. So what this does, request animation frame, it gives you a slot where you can execute your code, any code you want, in the next frame. So you can see that the monitor has a refresh rate. For example, mine has 60 Hz, which means it will refresh 60 times per second. But when we are talking about animations, we measure that with FPS, frames per second. So if the animation is 60 FPS, which means it matches the monitor refresh rate, then you will get the best performance. So when we say request animation frame, we get a slot like in the next frame where we can do anything we want. And you can see we are executing this function. So what we are doing here in these 3 lines is calculating this rotation value. And then we are using that value here which we are setting the styling for the transform property, and rotate. So what this does, it just updates the styling for this transform with this value. But that will only affect the next frame. And with that, we can't have an animation unless we also go to the other frames after that. And that's why we are calling request animation frame again here, and we are passing the same function. So that means it will get like in an infinite loop, and it will execute this one, but each frame will have a different rotation value, which will make the box rotate infinitely. So yeah, that's it for request animation frame. Now, do you see the main difference between request animation frame and WAPI and CSS? You can see in request animation frame, we have a high level of control over the animation, which means we can control the animation at the frame level. So you can see we can modify the styling property for that box at the frame level. For each frame, we can calculate the value here and then use it here. And you can do whatever you want. Whereas in the WAPI and CSS, we just declare the animation using these keyframes and some options, and then it's run for us behind the scenes. And this is key to understand because this will show you why this one was affected by the main thread when it got blocked, but the WAPI and CSS one weren't affected. Now, before I go into more details, let's see how the blocking code works. So you can see, first we are getting the block main thread button, and then we are attaching a click listener, and then we are calling block main thread and passing the number 5, which is the number of seconds that will block the main thread. And the important line here is this while loop, which would just keep running and it will get stuck here until 5 seconds pass. So while it's running here and it's stuck, then it can't reach any other part of the code here, including the one we have in request animation frame. So if we are in request animation frame and we are running this code to update the styling property here, and then it got into that while loop, then it will just get stuck and then it will stop running this animation, which would make the animation appear as either stuttering or completely frozen. But now the question, why it just affects this one but not the WAPI? And actually, it also can't reach the WAPI code and the CSS, but it doesn't affect them because they are not executing here. So what we are doing here, we are declaring the animation, and then we are sending it to another thread where it gets executed there. So even if the main thread is blocked, it can just continue executing that on the other threads. And speaking about threads, let's see a quick introduction to threads. So the simplest definition for threads is that a thread is a unit of execution where each thread has its own code where it can execute it in parallel with other threads. So if we have these 3 threads and each one has its own code and we are executing them, then they can execute in parallel. Even if one of them got blocked, the other 2 can keep running smoothly without being affected. So for example, if the first thread is the main thread and executing the code we saw here, and then it got stuck in the while loop, and then we are running the animation in another thread called the compositor thread, then the animation can keep executing here smoothly without being affected by the main thread. But now, another question you might have is why we can execute WAPI and CSS animations on a different thread, whereas for request animation frame, we always have to execute it in the main thread. And the reason for that is because in the request animation frame, we have this level of control at the frame level. And since we have this level of control, then we can access anything we want while we are preparing for the next frame. For example, you can access the DOM elements and get any value you want. But these DOM elements are only available in the main thread. And if you are executing the code, the animation code, on a different thread, then you can't access these DOM elements. So that shows us that request animation frame is the slowest, but the most powerful and most flexible one. For example, in WAPI, you can't do anything other than preparing these keyframes and these options and then send it to another thread where it can just use these keyframes and these options and execute the animations using that. And you can't do anything in mid of the animations. So does that mean if we use WAPI and CSS, we will always get the smoothest animation possible? Well, that's not true, because it does not only depend on the animation method, it also depends on the property you are animating. So for example, we are using here transform, But if I use something else like width or color, then it will not get the same smooth animation. And let me clarify that a little bit. So you can see here, we are seeing the simplified version of the rendering pipeline. So what you are seeing here is the list of steps that we need to go through in order to render a frame. I'm not going to get into the details of each of these steps as this is way beyond the scope of this video, but what you need to know is that in order to render a frame, you need to go, for example, through CSS JavaScript, so you trigger the animation or the styling change, you calculate the computed styles for that element, then you calculate the layout, then you paint that layer, and then you composite them. And depending on the property you are animating, it can either execute all of these steps or skip some of them. For example, if you are animating the width property, then it has to go through layout, paint, and composite. Whereas if you animate the color property, then you can skip the layout and just go to paint and then composite. And there are a list of CSS properties that we call them the compositor-friendly properties, like transform, opacity, and filter, where you can skip all of these and go directly to the composite step. But now, why this is important and how does this affect the performance? It's because of this. You can see that all of these steps, except the last one, are always run on the main thread, whereas the last one can't be executed on the compositor thread. Which means if the property you are animating hits any of these steps, then it will always go to the main thread, which means it will be affected by the main thread if it got blocked. Whereas if it can skip all of these steps and go directly to the composite step, then it can just bypass the main thread and go directly to the compositor thread, which means even if the main thread got blocked, it can just continue executing without being affected. So when we say, for example, that the transform property can directly go to the composite step, then that means it can skip the main thread and directly go to the compositor thread. And that means it will run smoothly. So in order to get the best performance for your animations, you need to get these two things right. First, use the right animation method, which is either WAPI if you want to use JavaScript or CSS animations, and animate the correct property. For example, transform, opacity, or filter. But sometimes you can't use WAPI or CSS because you want your animations to be flexible. For example, if I want to animate some element where it will follow the cursor, then I have to use the request animation frame because I can't specify the keyframes to follow the cursor. This happens based on some event. So in that case, I need that level of control where I can execute the animation at the frame level. But if you don't need this and you can just use transform or opacity, then go with the WAPI or CSS and then use that property and you will get the best performance. So now, whenever you hear the question whether CSS is faster than JavaScript, you can say it doesn't matter. What matters is the way you animate, the animation method, and the property you are animating. So I hope you found this video helpful and see you in the next video. Thanks for watching.